Good day everyone. Today we will be discussing an important concept in food safety and preservation under thermal processing. Specifically, nag-focus on problem solving involving the D value and Z value. So, so now let's begin. So now let's move on to a sample problem focusing on the D value. So in this scenario, a seafood processing company is sterilizing canned tuna to ensure food safety. So during processing at 126 degrees Celsius, a microbiologist observes that the number of microorganisms decreases from 10 to the power of 6 to 10 to the power of 3 in 6 minutes. So the question is, how do we calculate the t-value based on this information? So, to solve this, 'di ba, we need to remember that ang d-value or ang decimal reduction time it is the time nga required to reduce the microbial population by one log cell or by 90% at a specific temperature. So, So now let's break down the given values and the solution step by step. So from the problem, we are given the initial microbial load or the NO, which is 10 to the power of 6, and the final microbial load or the MT is 10 to the power of 3, and the time of processing is 6 minutes. So using the formula for D value, so ang formula is D equals time over log NO minus log NT. So now we substitute the values into the equation. So D equals time is 6 minutes. So we put it in the numerator. Then over log NO or the initial microbial load is 10 to the power of 6 minus final microbial load is 10 to the power of 3. Then copy the after that copy then d equals copy the numerator, and then if you have scientific calculator, the logarithm of 10 over 6 is 6 and the logarithm of 10 over 3 is 3, so the difference is 3 log cycles. So d equals 6 minus 3. So the answer, the d value is 2 minutes. So as shown in the solution on the slide, this confirms that it takes 2 minutes at 126 degrees Celsius to reduce the microbial population by 90%.
Good day everyone, my name is Benjamin Lopez and I will be explaining a sample problem involving D value and Z value. And now let us look at the sample problem. A microorganism has a D value of 10 minutes at 60 degrees Celsius. When heated at 70 degrees Celsius for 5 minutes, the population decreases from 10 to the power of 6 to 10 to the power of 1 cells per milliliter. So we are asked to find the D value at 70 degrees Celsius and the Z value. First, let us look at the given data. The D value at 60 degrees Celsius is 10 minutes. The initial number of microorganisms is 10 to the power of 6 cells per milliliter, and after heating for 5 minutes, it was reduced to 10 to the power of 1 cells per milliliter. We are asked to find the D value at 70 degrees Celsius and the Z value. To solve for the D value at 70 degrees Celsius, we use the formula log NT equals log N0 minus time over D. Substituting the values, we got log of 10 to the power of 1 equals log of 10 to the power of 6 minus 5 over D at 70 degrees Celsius. Simplifying, log 10 to the power of 1 is 1 and log 10 to the power of 6 is 6. So we have 1 equals 6 minus 5 over D. Rearranging the equation, we got 1 minus 6 equals negative 5 over D, which simplifies to negative 5 equals negative 5 over D. Solving for D, we got the D value at 70 degrees Celsius is equal to 1 minute. And next, we solve for the Z value. We use the formula Z equals the change in temperature divided by the logarithm of d1 over d2. The change in temperature is 70 minus 60, which is 10 degrees Celsius. Substituting the values, we got 7 z equals 10 over log of 10 over 1. Since log of 10 is equal to 1, the z value is equal to 10 degrees Celsius. We can summarize the results in a table. At 10 degrees Celsius, the D value is 10 minutes. At 70 degrees Celsius, the D value is 1 minute. And 80 degrees Celsius, it becomes zero point 0.1 minutes, showing a tenfold decrease for every 10-degree increase. So in conclusion, the D value at 70 degrees Celsius is 1 minute and the Z value is 10 degrees Celsius. This means that for every 10-degree increase in temperature, the D value decreased by 10 times. And that's all for my part. Thank you everyone for listening.